Okay, so for this video, we're going to take a look at the Chapter 4B review number 12A, which is a system of inequalities. And in both cases, they're going to be parabolas. Um, and so I'm just going to lead you through this so that you have kind of a review problem that you can use. So let's see. To start, I'll do the first equation I'll label 1, or the first inequality I'll label 1, the second one I'll label 2, and we'll address each of them by themselves. So for 1, I want to look at the boundary first. So the boundary line or curve is basically, if I treat it like an equals, it's y equals x minus 2 squared minus 1. And that one's in vertex form, so right away we know the vertex is going to be at the point 2, negative 1. And then we need some other coordinates, so let me make a little table here for it. So x's and y's, and I'll put the vertex in the middle, so 2, negative 1. And let's see, if I plug in 1 and 0, I get the same answers as if I plugged in 3 and 4. So let's try 0 since that one's easy. So if x equals 0, then let's see here, then x or y is going to be 0 minus 2 squared minus 1, which is going to be 4 minus 1, which is 3. So then I know when x is 0, I get 3. And so similarly, when x is 4, I should get 3 because of the symmetry. And if x is 1, then y is going to be 1 minus 2 all squared minus 1, which is going to be negative 1 squared, which is positive 1, minus 1, which is 0. So I get 0 here and 0 there. So that's enough to graph the boundary. And notice up here, it's a greater than sign, not a greater than or equal to sign. So I'm going to draw my boundary line or curve with a dotted segments. So let's plot these points. So let's see, I'll go 1, 2, 3, 4, 5, 6. Actually, let me do that in black. So 1, 2, 3, 4, 5, 6. And how far out do I need to go? Up to 4 so far. So let's go 1, 2, 3, 4. 4. 1, 2, 3, 4. And then we'll plot the points that we have. Oh, there's also a negative 1 in the y's there. So if I plot the points, I've got 0, 3 right there. I've got 1, 0 right here. I've got 2, negative 1 right here. I've got 3, 0 right here. And I've got 4, 3 back up here. And then remember, it's a dotted curve. So it's going to look something like this. Okay. And it says label the boundary lines or curves with their equations. So make sure that you label this one y equals, because the actual dotted parabola is y equals x minus 2 squared minus 1. And then to figure out the shading part, let's test a point, one that's not on the curve itself. So 0, 0 is a good test point. So if we test 0, 0, then I'm going to plug it back into the original inequality. So I'm checking, is 0 greater than 0 minus 2 squared minus 1? Well, that's going to be, is 0 greater than 4 minus 1, which is 3? And that's false. So I'm not going to shade the side that has 0, 0 in it. I'm going to shade the opposite side. So I'm just drawing the arrows now because it's a system, so I'm going to have to draw another one and then double shade one part. Okay, so let's look at the inequality number 2. So number 2, the boundary for that one is going to be y equals negative 3x squared plus 6x plus 2. And let's get the vertex for it. It's in standard form. So the x coordinate is just going to be negative b over 2a. So that's going to be negative b is negative 6 over 2 times negative 3, which is also negative 6. So this is positive 1. And then the y value is going to be negative 3 times 1 squared plus 6 times 1 plus 2. And let's see, that's 8 minus 3, so that'll be 5. So the vertex here is 1, 5. And then we can make a little chart for it, x's and y's. And I'll put 1, 5 in the middle since that's the vertex. So I could plug in 0 and -1, which would be the same answers I got as if I plugged in 2 and 3. So let's try 0 since that one's easy. So if x is 0, then y should be -3 times 0 squared plus 6 times 0 plus 2. So then that comes out to just be 2. So if I plug in 0, I get 2, which also means if I plug in 2, I get 2. And then, I don't know, let's try the -1. So if x is -1, then y is going to be -3 times -1 squared plus 6 times -1 plus 2. And so that'll be -3 times regular 1 minus 6 plus 2. So that'll be -7. So then I get a -7 here and a -7 there. So now I've got 5 points to graph for that. So let's see, these y's are going to have to go down further. So -2, -3, -4, -5, -6, -7. Okay, so let's plot those points. So we've got -1, -7. Oh, I need to go back one also. -1. So -1, -7 is way down here. And then 0, 2 is suddenly way up here already. And then 1, 5, 1, 2, 3, 4, 5. 1, 5 is right there. And then 2, 2 is right here. And then 3, -7 is all the way back down here. And if we look at what was given, it's a less than or equal to sign. So then I'm going to use a solid for the boundary. So this one isn't a dotted, it's a solid. Sorry, that looks terrible. Let's do that again. There we go, that's a little bit better. Right there. And in this case, we could also test 0, 0. So, because that's definitely on the inside of this thing. So if I test 0, 0, then let's see. I'm going to plug it back into the original way over here. So I'm checking, is 0 less than or equal to -3 times 0 squared plus 6 times 0 plus 2. And if you work that out, is 0 less than 2? Yeah, that's true. So we shade the side that has 0, 0 in it. So that's the inner part of this parabola. And so then the final part that gets shaded is going to be this region right here, the part that's double shaded. So let me get that all colored in. And there you go. So that's what your region looks like. And that's the final solution. Okay, hope that helps a little bit.